Good afternoon, student. Today, during the session, we discussed address calculation in single dimensional array. The concept is a very easy concept. Okay, the simple thing you should know is how we are accessing an element while writing a program. If you know this, the other things are very easy. For making you to understand, here I am displaying one image. So in this way only we will refer to the array elements. So there are 6 elements in an array. How we will access the element using the concept called subscript. A of 0 is none other than 15. A of 1 is 7, A of 2 is 11. For the user's convenience, the programmers used logical address to access the element while writing a program. But actually, these elements were stored in memory with different address. They are called as physical address. Here in your book, they given you a term called address of an element or actual address, or you can say it as a physical address of an element in a memory. Okay, and the starting address or starting element with an address is called as base address. Here the element 15 is started with an address 1000 and 100. This is actually the base address of this particular array. And each and every element may have some specific size, width. Here now look into this diagram, 1100, and the next element is stored in 1104. Next element is stored in 1108, then 12, 16. What is the difference between these locations? 4. All the elements were incremented 4. Why 4 bytes are incremented? Because as this is an integer array and the integer element is requiring 4 bytes of memory. Okay, to store an integer element you need 4 bytes. That's why 4 bytes of memory is allocated, and there is a difference between 4 bytes after each element. Okay, you know array. Yes, array is a contiguous memory representation. Elements will be stored continuously. Based on the width of an element, the memory will be allocated continuously. So this is what stated in this diagram. Now you know the base address, the width, and also the lower bound. Lower bound is, for this array it is 0. So always the array subscript starts from 0. And the array size is 6 elements. Imagine your array is having 1000 elements, 1000 different elements, and you want to know the actual address or physical address of 927th element. How will you calculate the address? How will you know the address of that particular element? Now to answer this question, formula is written. Now it is your duty to remember this formula. Address of an one-dimensional array. How to calculate address of an one-dimensional array? This will be calculated using A of I is equal to B plus W into I minus LB. So these all terms just now we learnt. B is a base address, W is a width of each and every element, I is an index, whatever you want to find out. Okay, now my case is 927th element. So in my case I is a 927th element, and LB is a lower bound. So here as per this case the lower bound is 0. And sometimes they will give you some other lower bound. So based on the question asked in board examination, you please refer the value. Okay, that's all. Now for your understanding I am giving you an example. See here. So here in this example they have given Array index starts from 1300 to 1900. Okay, so what is the lower bound here? 1300 is the lower bound, and they asked you to find out element address value for 1700. So I value is 1700, base address is 1020, and size of each and every element is 2. All the values were given. Simply substitute the same in the formula and get to know the value. So this is the formula for one dimensional array. Now next, address calculation in two dimensional array. Two dimensional in the sense row and column index has to be used. Now in this case, how will you arrange the elements continuously in memory? No worry, there are two ways were followed. One is a row major order and column major order. So first row will be placed, then second row, then third row. Similarly, first column will be placed, second column, first zeroth column, first column, second column, third column. So row major order, column major order. Either you can arrange the elements using row major or column major. So that here you have to remember two different formulas. So look at these formulas. Okay. A of ij, row, index of row, index of column. B is a base address. W is a width of an element. N is a number of column. I is an index. Yes, that will be given in your problem. LR is a lower bound for row. LC is a lower bound for column. That's all. Now, if they asked you, or if they given you a example problem, you just have to extract what is B, what is W, what is N, and simply substitute the values here and read the question one or two times whether they are asking for row major or column major, then substitute the values accordingly. Okay, definitely you may expect 2-mark questions in your board examination. If this particular topic is important topic, only thing you have to do is understand the concept using the image shared with you, and please learn the formula. If you are thorough with all the components present in the formula, then it is very easy for you to solve the problem. That's all easy. Bye.